Hi, this is Brent here with Theoretically Practical, and today we're going to be adding all the extra features to an old Miller S22-A 24-volt constant speed wire feeder. This may apply to other wire feeders as well, but you're going to have to do a little bit of figuring out with the wiring diagram, though I suspect most Miller stuff in this general category and general age is going to be very similar. So, why do we want to add those features? Well, you get pre and post flow of the gas, which I'd like a little bit of pre and post flow in almost any situation. It's just going to help keep your welds just a little bit cleaner, and I need all the help I can get. The other two settings are spot timer. For if you're welding body panels, you can set a time so that every time you pull the trigger, it only fires for a specific amount of time. That's really going to be good for welding body panels, getting a good consistent bead, and so all you have to do is focus on positioning your hands, not timing it as well. It's a pretty nice feature to have, and the final feature is burnback, where it keeps the wire electrified for a specified amount of time after you finish pulling the trigger. This is handy because I've noticed a lot of times I'll end up with a little ball on the end of my weld, and that's a sort of a sign that your burnback is set incorrectly, but I can't change it right now. The other problem with this little ball on the end is when you start welding again, it almost always immediately contaminates it. So I've kind of trained myself now to notice the ball, cut it off every time. It's just one more thing I need to do. And so I want the features. So why don't I just go out and buy the boards? Why shouldn't you go out and buy the boards? Well, you can't. I actually looked on eBay to find comparison prices, and at this age machine, you get nothing. If it was newer, $200 to $400 an option card, it's crazy money. So I really want these options, and you cannot buy the option cards. They're horrifically expensive. It'd be $400 a card, perhaps, if you could find them. I don't even know. They're not available. They're unobtainium. So either you got it or you don't. And if you got it, it could break on you. So here's how to build yourself a replacement using an Arduino and, $30, $40 in stuff. All right, so we're looking in here, and geez, there's a lot of wires in there, isn't there? But that's all right. Don't be intimidated. We will figure it out. So we're gonna go look at the wiring diagram and look at the diagram for the plugs that are also available, and I'll kind of try to tie it together. So if you look at it, they both say under the pre-flow and the post-flow option, and if you do both of them, that you're going to be using PLG1, DF, CB, A, and E, those wires. There's a little bit more to it, but we'll go into it. So if you look at the diagram of the welder, there's a little bracket that says optional, remove jumpers and connect to spot, burnback, and or pre-flow, post-flow option. And that's called RC1, and you see they have A through E, the 6 connectors there. Now, the one said PLG1 because that's the plug, and the RC1 is receptacle one. So that's how you know that those two go together, and also, it's got notes about remove jumpers and all that stuff. So where is the, where is that plug on the board? And we're gonna look in there, and we're gonna see there's no plugs back there. There's a 6-pin plug there. That's probably, I'll get right there. There's a 6-pin plug there, but if we look over here, there would be receptacle 3 is also a 6-pin plug that does a lot of important things, and it goes to the terminal. So that's probably not our jumpers. So we're looking for 2 jumpers. So, and then you get over to this side, and there's an 8-pin plug there, which can't be it. And then there's this plug here, which is 6 pins, and the only thing connected to it are these 2 loops of wires. So this is your receptacle, and these are your jumpers. But if we also look at it, we also can see that there's a note on the wiring diagram that says remove jumper for pre-flow, post-flow option, and that jumper was attached between B and C right right there. So you can see on the top, yeah, there we go. A, B, and C. Between B and C, there was a little jumper. Is this tiny little piece of metal connected to the bottom two, but I lost it when I took it out. The other thing to look at is on the pre-flow, post-flow option part, will be 1 in 35. It says 2 IT terminal strip. And if you look over the A and the B below that on the drawing in the upper right, you see 1 in 35. That should also be noted. So anyways, what I started doing is trying to figure this out. So I used a voltmeter mostly in voltage mode. So to see what's happening when you take this in and out and what you can connect to what. What I ended up figuring out was that the RC1A to D, which is the two furthest away ones, connecting that to that with the trigger pull. The trigger has to be pulled for this pin to be active, the far left pin. With the trigger pull, that to that will turn on the motor. With the trigger pull, that back left pin to the middle right pin will turn on the power of the unit, and we'll go through and do that in just a minute. And then there is a signal, but it's a very low milliamperage signal from the back left pin to the front left pin. That signal is a 22 volt signal, but it's our 24 volt signal, but it's very, very small. I'm not actually sure that it's meant to be a signal, but it's the only thing I could find that I could pull information from. So, and then the two bottom left and right pins are those are the 24 volt power DC that you would use to power the option cards, and that's where we're going to pull power from the thing. This one is negative 24 volts. This one is positive 24 volts. The jumpers would have been from here to here and from here to here. If you jump from here to here, you'll turn on the motor. If you jump from here to there, you'll turn on the power at the unit, at the welder unit below. This pin doesn't seem to do anything all that useful that I can probe, but this pin to this ground pin also provides a very low milliamperage 24 volt signal that I can intercept to the Arduino. So what do you do when you have a 24 volt signal like that that's really low milliamperage? I went to Automation Direct, picked up a relay. Way too much amperage pull. I kind of knew that. I had some other thoughts about this, but I've already gone through this with a meter a bunch of times. You kind of want to go through the drawing in the meter back and forth until you have a real understanding of what sort of signals you're dealing with. So I tried this. I got nothing. It didn't want to fire. It will fire though when I connect it up, so it's not a bad relay. So okay, well, I know that SSR, solid state relays, switch is a lot easier. This is a 3 to 32 volt DC input, so 24 volt DC is perfect for that. I plugged it in and I got a very dim light on that, which means that it's kind of doing something with these, but not really. So then I dug into my toolbox of fun at work and I ordered something that I use at work an awful lot because I like them for signal isolation, stuff like that. And that is a Wago 859-7094. These are like out of 10 or 15 bucks a piece. It's a DIN rail mount optical isolator. What an optical isolator means is you've got your A plus and A minus here, and you can see there's the symbol for an LED right there. And then there's a signal for what's called a collector here. So what's happening is in order to keep this side electrically isolated from this side, if you look through, it's going through a few passive components, resistors and whatnot. There's a little LED as an indicator light. And then this is called an opto-isolator. Well, this is the heart of it. So inside of this is packaged an LED and something that senses the LED's output. When the LED turns on, the output turns on. They're only good for switching very small signals, but this one has a rating of DC 60 volts max, 0.1 amps. I also did some looking up. This has the lowest amperage draw. This draws like, this needs like a signal of like at least 4 milliamps or something to that effect. So it only needs a very, very small signal to turn it on and off. All right, so I've connected up the Opto-isolater. Now the electronics of my Arduino don't need to share a ground with this welder or anything like that. They can kind of be on their own, which is, for this, probably pretty ideal. So we're gonna turn it on. When we pull the trigger on this very low amperage signal, we're gonna look at the LED light that lives right in there, and we should see it turn on and off as I pull the trigger. So there's the light on and off for that. So we've gone through this whole thing. We've marked it all up, and there'll be a marked up version of it in the description. I know I'm kind of skating over a lot of the how I figured out where things are where, but you know, or what signal's coming from where. But I looked at the diagram several times, really thought about it. It seems simple on the face of it, but you really want to look at it and look at it and look at it some more and really understand it before you dive in. Because again, you know, you could do something like damage your voltage regulator, which apparently I probably did. But that's okay. We're gonna deal with that in a different way, I think. We're not going to use that power, so it shouldn't be a problem. So then you've got your diagram, which you'll have RC1A to D, say, you know, connect to for feed. You're going to have your RC1D to F, or D to F is going to be your signal through an Opto-isolater to let you know the trigger is pulled. You're going to have your D to B, which is going to be your turn on the power system signal. And then if you look at the backflow postflow option, you see there's 1 and 35 to IT terminal strip. Well, you go over to the terminal strip, and 1 and 35 are A and B, so that's A and B connected together to get the relay to fire for the gas. The gas relay is right there, and we'll turn it on. And if I can find, yep, I got some test leads. We're gonna turn it on, and we're gonna short them together so you can see that that's how you fire that off. So A to B should fire the solenoid. And you should be able to hear that click and see a little spark. So one thing we should note that that little spark, anytime you fire off a solenoid, you're charging and discharging a coil, just like the coil in your car. So it does produce a spark when you disconnect it. I don't think I'll have a problem because I'm using, again, optically isolated relays from the Arduino, but I've had issues with signals like this giving them problems before. And what you can actually do is put between A and D, is put a diode between the two of them, or you can put it on the relay side. And all that does is it prevents the voltage from traveling. It gives the voltage a place to go when it's not being pushed in the right direction, and that'll cut down that noise that it'll produce. So if you're doing stuff with big solenoids and you're having problems, the answer is diodes. I'm not going to go too into detail with that. There's just so many other videos on the subject, it doesn't seem worth it. So what I'm going to go do now is I'm going to go take my jumper unit here, and on this I need 1, 2, 3, and 4 wires. So I'm gonna have to move this one to there and cut them in half, and then I'll have my connector for there. I'm gonna figure out where I'm gonna pull power for the Arduino unit, but I think I wanna use the 120 volt power for that. That is switched with the main switch. It won't be switched off with the front of the welder anymore, but that's fine. So we're gonna figure out the power situation, and I'm gonna go wire up an Arduino and program it, and we're gonna come back, which is a mouthful. But there will be a second video where I show the Arduino code. It'll be posted below so that you could do this as well. There'll be a basic wiring diagram and a parts list so that, you know, this isn't necessarily meant to be a tutorial, but if you are electronically inclined, you certainly could follow it and figure it out without too much trouble, which is really what I'm going for. So yeah, all right. All right, so I'm gonna probe out the pins on that 6-pin connector just so you can see where I'm getting my voltages from. These first 2 pins, my voltmeter is reading 32 volts. I think that I may have burnt out a voltage regulator on the board with some of my testing. You know, mistakes happen. I don't think it's gonna bother what I'm trying to do at all, but it was 24 volts the last time I checked it. I think I shorted something stupid. Okay, we're back. I did some more testing with the voltmeter and a few other things, and I had this moment where I was convinced, absolutely convinced, that I had blown up the voltage regulator in it, except that I actually checked the voltage regulator in it, which is like an LM317. Don't think I know that off the top of my head. It's written on the top of the chip, or I'd have no chance of figuring it out. It's also a single layer board, so you really just gotta follow the bouncing ball, and you can figure out where most things are. But I suspect that my voltmeter may have been telling me lies. As you can see, it's in the off setting, and we have negative 38 somethings for sure. It is displaying battery. It could be the battery is low. This thing's reading about 10 volts high. So that output there is reading 32 volts. I thought it should be 24. I thought I checked it the other day and saw 24, but that was with the suspect meter. I've tried 2 other meters with it. It's saying like 32. Everything else seems to be working. I'm gonna check it regularly for a little bit, make sure that that voltage regulator isn't dying on me. But since I didn't write down, I'm not positive that that was the voltage I saw. I can't be sure anything's changed. So in any case, I'm gonna assume that it's good for now because that's what I wanna do. So let's look at what we have here. We have our panel that came with the machine, and we've put 4 potentiometers on it and a double pole, double throw switch. So we've got this. So this is going to tell you if you've got spot mode on or continuous. You're going to be able to set your spot timing. You're going to be able to set your burn back timing, your pre-flow, and your post-flow. Okay, so I have decoded how I'm going to use that 6-pin connector. So the pins are A, B, C, D, and F, and this is the tab, just to give you an idea of orientation in the machine. So F is ground, C is 24 volts, D to F with an opto-isolater in the middle is your trigger signal. I did verify that works. C to A C to A normally open through a relay will control your feed. C to B normally open will control your power, like it turns on the power on the unit below. And then on the terminal block, terminal A to terminal B, which are not these two, they're a terminal strip inside the machine. These are all Miller's naming conventions, so don't blame me too bad for that. So A to B is gas. So what we have to control that is you have the opto-isolator. This is going to receive the signal. You have this is a UBEC is what's called, I don't know, Universal Battery Eliminator chip, I think is what it means. It's from RC cars, but what it is it can take a wide range of DC input voltage and output 6 volts. 32 is a little bit beyond what it is, but it seems to be okay with it. And I did actually order the right size one, and these are like $5 each. So if it dies, I'll move on with my life. So I've got 4 relays. I only need 2. These are the Songle brand relays that they sell for Arduinos. They make Omron ones. I ordered the Omron ones, but these are what I had in my bag of tricks. So these are what we're going to use. These are also, see the little square chips in the middle? These are also opto-isolated, which means that it helps protect the Arduino from the flyback voltage, which was what I was talking about with turning on and off the gas solenoid. So we got this and this and this. We have a little enclosure that I'm going to put the Arduino in. Here's the Arduino. This is an Arduino Pro Micro. Whether or not you can read it, it says it right there on it. I have a lot of these around because I like them because they're small, they're cheap, and I mean, even if you buy them from like SparkFun or Adafruit, they're like $20. They're great. This one has way more inputs and outputs than we need. But it does have A0 through A3 right there, which are your analog inputs. And then we're gonna use pin 6 for digital input and pin 7, 8, and 9 for digital output. So what it's gonna be is we're gonna have our analog signals from the potentiometers that we're going to take those in and read those in as a number between 0 and 1024. It will take those in and convert them to, in this case, 1/4 to 5 seconds for the spot timer, and for the burnback 0.02 to 0.25 seconds, and for the pre-flow 1/4 to 5 seconds, and for the post-flow 1/4 to 5 seconds. There will also be another input for this, which is the spot mode or continuous mode. One more thing is I had a spare cable for my power supply. It's a Corsair brand, but this connector was the same as the one in the welder. The only thing is that it only uses 5 pins, and I had to switch a pin from here to there. I won't show you my depinning process because I don't have the right tools, so I made it happen. Get the right tools. It's like $5 or something. I don't know. I just jammed some wires in next to it, wiggled it around, was able to free it up, and then I had to bend the wings back out because, of course, I mangled them with my terrible methodology, and then slide it back in the other hole. It was on the opposite one. So now I got this great cable, and the other thing is I get to leave this bad boy alone and in the case, so that I could, the way I'm doing this conversion, I'll be able to zip tie this up out of the way. So if the Arduino died and you desperately needed to weld or didn't want to deal with it, which is the more likely scenario, you've got your jumpers here, and the only thing you'd need to do is jump A to B on the terminal. And if I hadn't lost that little clip of metal, even that would be pretty easy. All right, we're gonna wire up the back of the control panel, we'll call it. You can see I've labeled minus and plus on the potentiometers and minus as the center pin of this switch. I labeled the center pin as minus because the Arduino has what's called a input pull-up pins built into it that you can invoke on digital inputs. So you actually connect that input to ground to get a signal on it. So they always read true until you give them a ground, then you read false. So they also invert the logic. But it means that you don't have an extra resistor, which is nice. So also, I'm using this cordless Milwaukee soldering iron. I have one at work. I really, really like it. And when you're using your solder, make sure it's rosin core solder. Acid core solder will work until it kills all of your electronics. Yeah. So I'm going to go forth and tin everything first that I'm going to solder to, and then I'm going to go back and connect the wires. I like to tin everything first. It just seems to make life easier. Got to breathe in that smoke. Okay, that's the control board wired up. I know it's not pretty, but it'll do just fine, and it's going to be inside of an enclosure. So otherwise, if it was going to be more exposed, I might heat shrink tube on it, make it look a little nicer. But this is going to be just fine. So I ran all white combination wires for the potentiometers. Orange is plus, brown is minus to there. Only one wire on the switch because if it needs to be turned into spot mode, I want to turn it to spot mode. But if this wire were to break or something else like that, I'd want it to default to continuous mode. So that's that step of it. That'll be it for tonight. I'll come back tomorrow. Not that it'll mean anything to you guys. And hopefully we'll finish this off. All right, we're back, and we got this board all wired up. I know it's not beautiful, but it's perfectly acceptable. But we got this little box we're gonna mount the Arduino in, and if I have enough room, I'm definitely not putting the relays in there. They won't fit. I'll probably just glue them to the outside of the lid, because that'll work out. You'll see how it works out. So anyways, I want to attach this to there, but obviously there needs to be a space, and in order to fit it in the welder, it needs to be offset in this direction. So it needs to go in like that, so it can slip in the hole. That can still screw in. So for that, I got some nylon spacers and nylon nuts and bolts. You don't have to use nylon, but I was already at the hardware store and it wasn't terribly expensive. So let me get that mounted up, and then we'll move on to the next thing. Okay, I got the hot glue gun heated up now. I like to use hot glue gun to put a lot of electronic stuff together because, well, it works really well. It's, you know, it's non-conductive. It sticks fairly aggressively, and you can undo it too, which is, it's almost as useful. So I'm gonna hot glue these two relays to this surface. I was gonna glue them on the side, like I said earlier, but then I realized that then it won't fit through the hole that it has to fit through. So they're gonna kind of come around and go through there, so you can open it up if you need to. So I'm just gonna take some Scotch-Brite and just rough it up, give it a little bit of a key to the surface. Probably don't even need to do this, but. All right. And we're gonna mount these bad boys just like that. So. All right, and we're also, these connectors tend to be pretty lightweight, and I've ordered them so the colors are the same, but these connectors tend to come apart, so we're just gonna put a dollop of hot glue around those as well. And you might have even seen this in consumer electronics. They usually don't use hot glue, they use like Celastic or something like that, but they'll glue the connectors in, just because, you know, an ounce of prevention is definitely worth a pound of cure in that instance. So, all right, so there's that. That'll be our cover. Just be patient, Brent, be patient. Okay, so we're all pretty well wired up here. I'll go through what we wired up and where and why on the Arduino. So the power from the power supply goes to raw, the positive side goes to raw, the negative side goes to ground. That's what you want. That's where the 6 volt goes in there, that's the ground. The power out to the relays and the potentiometers comes from VCC, which is the 5 volt controlled voltage, and then that other side of that is connected to ground. So that's connected to ground, that's connected to VCC, and then you have the 4 white and other color letters, and those are the analog inputs, and they are A0, A1, A2, and A3. And again, the order is not that important because I'm gonna set it up on my computer with an output and just test them and figure out which color is which. It's almost easier than keeping track of it from the beginning. On this side, you've got 9, 8, 7, and 6. Those are for the 4 relays. I know we're only controlling 3 things, but it's kind of easier in case I want to add something for some reason. It's easier just to make that connection now. 4 and 5 are inputs. 5 lets me know if it's going to be spot or continuous. 4 is this to this is going to simulate pulling the triggers. So these 2 are going to connect to the Opto-isolater here, which is going to connect to 2 pins. We're going to be using our chart that we figured out the other day, and yeah, it should be pretty easy. So there's going to be 2 additional lines that come off of one of those relays that go to the A and B terminal connections for the gas, but then C to B and C to A is going to be the feed to turn on. F to C is going to be attached to these 2 to give us power, and yeah, and then D and F on this are going to connect to the Opto-isolator. So I'm going to test all this, get the Arduino part working, and then we'll come back and we'll finish up the wiring. All right, we're back, and this time we've got the blinking lights. So I now have it set up so that it's got, we'll put it on continuous mode now, and it's got pre-flow, a little bit of pre-flow, a little bit of post-flow, and we're gonna put burn back up all the way because it's really short. These 2 wires are where we're gonna hook up to our Opto-isolator and get our trigger signal. So when I push that, it's just like pushing the trigger on the gun. So gas on, feed and power on, and then when I release, you'll see the power relay turn off quickly, and then the gas relay turn off a little bit after that. There we go. And then we've got spot mode, where we have a spot timer. So and you can see it turns off. I also programmed it so if you were spot welding and you want to let go, it still follows the post flow and the burn back procedure. So you can either press once and let go, or you can press and hold until it's finished. I felt like giving you a way to bail out was a better idea. So anyways, that all works. So I'm gonna stuff this into the box and get it all wired up. I'll get the whole thing situated in front of the welder. I'll show me wiring it up, and then we'll show it in action, and then that's it. We've got, you know, $400 or $500 worth of features for, you know, an afternoon of dinking around with Arduino. You can't go wrong with that. Okay, so we're over at the welder now. I fiddled around with it. I figured a few things out. I gotta actually disconnect these 2 to slip that through the hole because these are fatter than I thought they were. And I have to mount the whole control upside down, as I would call it, but you know, I'm not gonna worry too much about that. The thing of wire ferrules that I will almost certainly just dump on the floor, but we're gonna go with that. These are a really great way of terminating wires. They're just, oh, it's just the way to do it. The crimpers are unfortunately expensive, but these are the crimpers to buy, you know. Oh, I'm just breaking everything up. Okay, we're ready. All right, see they're nice and crimped and connected together, which is this one. Okay, so this won't do anything yet. Come on. Okay, but it should turn the Arduino on, and we should be able to pull the trigger, and that's sort of where I want to be at the moment. Those are just for that. Those are wide open. All right. the trigger. So we gotta remember also, this one is the gas one, and this one is the feed, and that one is the power. I know that because this comes on first. Those two come on at the same time, but the feed is the first one to turn off there. So we've got gas, feed, power. I'm just gonna probably find a Sharpie and put G, F, and P on them, or just hope. Okay. So now we're really starting to feel like we got somewhere with this. I'm pretty excited about this at this point. So we're gonna be in continuous mode. Burnback is gonna be set to maximum because otherwise you won't notice it. Post flow is gonna be about there. We'll turn it on. So I'll actually do it this way. So you'll watch, you'll hear the, maybe I can even turn the gas on. It'll hiss a little bit. You'll hear the hiss of the gas, and then you'll see the wire start to move. So I've got the trigger pulled, hiss of the gas, start feeding. Okay, we're gonna set spot mode. We're gonna set it pretty low. All right, so you'll see, I pull the trigger, pre-flow, flow, stop. Everything shut off. Release. Yeah, everything's working as anticipated. And we'll switch over to continuous mode and so that's good. All right, well that's, yeah, we'll turn the pre-flow all the way down and we'll see how that works. Yeah. So if you're doing some spot stuff, you didn't mind having almost no pre and post flow. Sure how consistent the timing is with an Arduino, so I'm just going to cut a few times and see what happens without changing any settings. I'm going to lose that wire somewhere. All right. So that's 3 wires cut similarly. And the length on all of them, hey, how's about that for the same length? I don't think I cut that accurately. I'm quite pleased with how this is turned out. So let me button this back up, clean the top of it off, and find a piece of scrap metal I can whale away on for a minute, and we'll play around with these things. All right, this is spot welding. That was not enough time for a spot weld. Now look at that, 3 nice, dainty, or 4 or 5, I can count, all the way up to 5 anyways. 5 dainty little dots, and so the burn back setting, I don't know if it can be seen. There's a tiny little ball on the back of this. exact setting doesn't do what I hoped it would do, but that's okay. I really wanted the spot setting, so if I ever want to do auto body work, I've got this lovely spotting feature. Okay, so here it is at the end of the day. There's one extra hole in the middle of that, but I can probably glue the head of the screw on there to make it look like it's doing something. You've got all 4 dials and adjusters. You've got the little switch, which is a very nice little switch, or just has a very satisfying click. Everything is upside down. That's why your picture is upside down. But it all works. It does what I want it to do. So on the whole, I'm going to call this a great success. I might have spent $100 on parts because some of the stuff I bought was wrong because it took me a while to figure out what was right. Hi, so that about wraps it up for today. That's pretty much the end of the Miller CP-300 welder project. Everything works the way I want it to. I feel like I did not really say thanks enough to, I think it's Aaron Haas and Dave Camp, the Haas Camp guys. I talked to Dave Camp on one of the forums, and he was very responsive and gave me a lot of really good information. So I felt like I didn't thank them enough in the first video. So thank you guys. You really made this possible. Yeah, so on the whole, I've been delighted with this welder. It's made a lot of things a lot easier. And now that I have pre and post flow, which I really help with the cleanliness of the welds. The spot timer is great, and I'm sure once I figure out how to use burnback, it'll mean something to me. But and as you can see with my wire length test, as far as timing goes, it's pretty stinking accurate. I mean, I'm not going to say it's plus or minus a millisecond, but 20 anyways. So that's it for today for Theoretically Practical. This is definitely practical. Have a great day.